Yeah, that's a bit annoying. All right, well, welcome back, everybody. Hope you had a good spring break. You may have had a chance to look at this. The average on the test, let me get to that here. See if I can. Okay, so the class average on the first exam, wait a minute, this is not you. Oops, that's not your class. That was my calculus class. All right, this is your class. So the average on the first exam was an 80.9 with a standard deviation of 14. And then this one, the average was a 76.95 with a larger standard deviation, which meant that the grades were a little more spread out. And so that's pretty, yeah, it's close. Let's see, the blue is exam 1, the orange is exam 2. So you can see we didn't quite have as many A's. We had a lot less B's, right? On exam 1, there was 11 B's. Exam 2, there's only 5. And then C's, D's, and F's. And then you can kind of see that over here. So the highest grade on this test was a 106.3. Is that for me? No, it's okay.
You need rags too, right?
I would love to have a rag.
Okay.
You have one?
I'm going to bring it to you.
Okay, thank you.
Yeah.
Appreciate that. Okay, so yeah, the highest score was a 106. I'm going to keep doing that. And there we go. Got some? Thank you.
Sorry, sir.
No, it's okay.
There you go. Thank you.
All right, no problem. Thank you. Does this make sense? I don't need to go through all this, do I? You just kind of get a feel here for, you know, if the students did okay on the second exam. These were kind of the same students who did okay on the first, and there are some that improved or, you know, went down. Just depends. So that just gives you a feel for where we are, okay, as a class. Did you all feel like the test was fair? I mean, I wasn't here, so did you walk in, were you like, what the hell? Or y'all were okay with it? Did it look like what I asked you to look at, the review? Okay. All right, so that's it. We're going to move on. So we are going to start off today with your doing something, your favorite word that begins with F. Factoring. So y'all ready for this? Factoring? We've already talked about factoring in this class. We've discussed one type of factoring, which was called GCF, which stood for greatest common factor. So whenever we look at an expression, we always want to try and do the GCF first, figure out what the greatest common factor is. And then after that, we need to see if there's additional factoring we can do. So I'd like to start this out. Let me bring this up real quick. Zoom this in here. All right, so when it comes to factoring, I want us to have like a set of steps, all right? That way, whenever we're taking our next exam, you follow some sort of procedure. The first step to factoring is to look for GCF, all right, greatest common factor. The next step is to count the number of terms. So what I'd like to do is explain this second step with an example. So we're going to do the first one over here. So on number 1 here, 15x squared minus 21x to the 5th, we start, if we're asked to factor it, we start by looking for GCF. So what would the greatest common factor be here? So the number that goes into both 15 and 21 is 3. And then how many x's do I have in common in both of those terms? X to the second power, right? So 2 factors. So I can pull out x squared. And then I put a set of parentheses, and I leave myself enough space for how many pieces that are going to go in here? 2. Okay? Since I started with 2 terms, if I factor out a GCF, I need to have in my parentheses enough space for 2 terms. And then what are these terms? So what do you multiply this by to get back this? You need a 5, right? And that's all you need, right? And then how about to get this? You need -7. That'll 3 times -7 will give you -21. And then x squared times what gives you x to the 5th? You need x to the 3rd power, right? So that right there is, I guess, step 1 over here. We have done GCF. So I'll just put that right here. This step right here was GCF. Now what we're going to do is we're going to count how many terms we have left. And what I mean by that is look in the parentheses and count the terms. So how many terms do you see here? 1, 2. Terms are separated by addition and subtraction, right? So we have 2 terms there. All right, now let me come back over here and tell you what we do, all right? If there are 2 terms, right? If 2 terms, then see if it is a difference of squares sum of cubes or difference of cubes. Now, what the heck do I mean by that? So, difference of squares, does that sound familiar to you? You've heard that before or no? Difference of squares? A difference of squares is anything that looks like this. Something squared minus something squared. That's called a difference of squares. Now, whenever we see a difference of squares, this is a difference of squares. Whenever we see a difference of squares, this always factors to be a plus b times a minus b. And this is just something you should just memorize. Anytime you see something squared minus something squared, this is how it factors. Now we can check it by multiplying this out. If you FOIL this out, what would happen? I know we just got back and you had a long break, but let's try here. So what would happen here times here? A squared. Here times here. You get a times b, right? But it would be negative. So negative ab. And then what about this one right here? It'd be plus, and then b times a, right? Or I could write that ab because, again, multiplication doesn't matter. And then what would the last one be? B minus, and then b times b, b squared. And what happens to these 2 middle terms? They cancel, right? So this a squared minus b squared, which is this, right, in blue, is equal to that. So whenever we see a difference of 2 squares, you need to memorize that turns into parentheses a plus b times parentheses a minus b. Does that look familiar or not? I mean, if you remember factoring from way back when, this is a pretty common one. Okay, so let's just go look over here right now. Does this look like something squared minus something squared? It does not, right? Like 5 is not a perfect square. Like if this was 1, maybe, right? Or if this was 4, or if this was 9, or if this was 16 or 25, right? A square, then we would be thinking this. And then also over here, this is x cubed. That's not squared, right? So this does not look like this. Do we agree? Okay, so it's not a difference of squares. So the next question is it a sum of cubes? So what does a sum of cubes look like? That's something that a lot of students are not as familiar with. So this was a formula that may or may not have been given to you in the past. It's basically the same thing we just had, except it's cubed and cubed here, and since it's a sum, there's a plus in the middle. So if you see two terms where it's something cubed plus something cubed, then this also has a formula for factoring. This one I don't expect you to memorize. On a test, I would give this formula to you, all right? The formula is a plus b. So far, okay? Okay. The next part's the ugly part. A squared minus ab plus b squared. So this factors to be this. If we multiply all this out, things would cancel and we'd be left with this. All right? Now, while we're here, let me show you the last one, which is a difference of cubes. So if you have a cubed minus b cubed, there's a formula for that, and it's a minus b. So this one has plus, this one was plus, right? This one's minus, see that minus? And now watch, the rest of this is a squared plus ab plus b squared. So this minus, this is minus, and then look, the sign goes to plus, and then this sign is always plus. Do you see the similarity between these two? It's like if this is plus, then it's plus minus. This is always plus. This is minus, it's minus plus, and then this is always plus. Again, I would give you the formulas, all right? So don't worry about memorizing. All right, so let's look back over here. Could this be a sum of cubes? No, because it's minus, right? Okay, so it can't be the top formula. Could it be this, a difference of cubes? Well, is 5 a cube? What are the cubes? What are the perfect cubes? What are the perfect squares? 1? No? No? How do you get your perfect squares? 1 squared, 2 squared, 3 squared. These numbers are what? 1, 4, 9, 16 would be the next one, 25. Those are your squares, right? So if you were to see like any of these numbers here, you'd be thinking the squares formula. Okay, but what are the cubes? So it's all of these cubed. So what's 1 cubed? 1 cubed? 1, 2 cubed? 2 times 2 times 2. 2 times 2 times 2. 8 is a perfect cube. 3 cubed? 3 times 3 times 3. 27. 4 cubed? 4 times 4 is 16 times 4. 32. 64. Okay, so at some point, yes, you don't need to know them. You should definitely be able to recognize 1, 8, and then 27. Those are the ones that you should recognize as perfect cubes. So right now, this right here is telling us maybe we have a difference of cubes, but these need to be cubes. So 5 is not a perfect cube, right? 7 is not a perfect cube. Now x cubed is a cube, but this 5 and 7 make it not a difference of cubes. Does that make sense? I'll do an example where we have a difference of cubes, but this does not fall into that category. So we don't have a difference of squares, we don't have a sum of cubes, and we don't have a difference of cubes, which means we are done. There's no more factoring that can be done, all right? So we would stop here, box up the answer, and be done. Okay? Now, that's if we had 2 terms. What if we have 3 terms? So this is if we have 2 terms. If there are 3 terms, we are going to use what's called the AC method, which I will do an example of. Let's just write it down and we'll get to an example, all right? And if there are 4 terms, we will do grouping. What if there are 5 terms? Well, then you're not in this college algebra class, you're in the Math 1414 class. And they go past 4. They go to 5, 6, 7, 8. But we stop here. We're going to stop at 4 terms, all right? Okay, so let's just recap this. If you're going to factor anything, first thing you're going to do is pull a GCF. Okay, that's the first thing you're going to do. Then you're going to count how many terms are in here. If there are 2 terms in there, you're going to see if it falls into one of these 3 formulas. Difference of squares, sum of cubes, or difference of cubes. If it doesn't, you're done. If it does, we have to do some work. Okay, if we count the number of terms and we get 3 terms, we're going to do this thing called AC method, which I haven't shown you. And if there are 4 terms, we're going to do this thing called grouping. Okay? That's the approach. All right, so let's do another one. Let's look at number 2. For number 2, we have 24x to the 4th plus 30x to the 7th. So do we have a GCF there? Do we have a GCF? Because that's always our first step. Is there a number that you can think of, the biggest number that you can think of that goes into both this and this?
6.
6? 6 goes into both of those. Okay, so 6. And then how about the x's? What do they have in common? We have 4. 4 factors of x, right? This one has 4, this one has 7. So you pull out what they have in common, which is the 4th. Then parentheses, space for how many? 2 terms. Okay, what's the first term? So what do you multiply 6 by to get 24? 4. And do I need to multiply this by anything to get this? No, once I multiply this by 4, I'm going to get this. Okay, then I put plus. Now I need 30. How do I get 30? 5. And then x to what power? X to the 3rd power. So when you multiply this times this, you get x to the 7th. Okay, so we've pulled the GCF. Any questions there? Now we look inside, count the terms. How many you see? 2. Okay, so it's got to, if we're going to have any success now factoring, this has to be either a difference of a difference of squares, sum of cubes, or difference of cubes. So I have a sum, right? So this cannot be difference of squares or difference of cubes. The only thing it could possibly be is a sum of cubes. Do you all agree? Now, 4 is not a cube, right? So you're done, all right? At that point, you're done. I mean, it doesn't matter that this is a cube. 5's not a perfect cube. 4's not a perfect cube. We're finished. Okay, so that's that one. Let's move on to the next one. All right. Number 3. Yeah, let's do 3. We'll go a little faster here. On 3, 30x squared minus 60xy. All right, GCF, always the first step. So what do we have in common here? It's the biggest number that you can think of that goes into both of those. 30 itself, right? 30 goes into both 30 and 60. So I can pull a 30. How about letters? See, we have an x here, and we have some y's in here also. So whatever you pull out has to be common in both. So here, what do we have in common? Just a single x, that's it. And then parentheses, enough room for 2. So what goes in there? 1x, or, okay, so to make 30, you need a 1 here, but to make x squared, you need an x also, right? So I could put 1x, but I'm just going to put x. That's the same as 1x. And then what would I need now? Minus 2y. So I already have an x. I just need to make the y, so I put a y here. I need to make the 30 become a negative 60, so I put negative 2. Okay, how many terms are left inside? 2, so it's got to be one of the formulas. And if you look at this, it's a difference, right? But we have two formulas, difference of squares, difference of cubes. Neither one of these are squared or cubed. So again, we're done. All right? Don't worry, we'll do one where we actually have to go further, but so we just box that and continue. All right, next one. Now we get to something a little more interesting. 8x cubed plus 12x squared minus 10x. So start with the GCF. The biggest number that goes into every single one of those terms. 2, right? 2 looks like the biggest number. Almost looks like 4 would work, right? Like 4 goes here, but 4 doesn't go into that. So 2. All right. How about in terms of the letters? Just 1x, one factor of x. That's all we can get out. And then enough space for how many? 3 this time. And then they will be, let's see here, 4x squared plus 6x minus 5. Do you all agree with that? Okay. Now, how many terms are left inside? 3 terms. Okay, so we have 3 terms here. And what did I say we would do if we have 3 terms? We would use the AC method. So we have not talked about the AC method in here, have we? I feel like we have. I don't know why. Maybe I had too long of a break. Where we did this thing? No? Okay. Yeah, it was too long of a break. All right, so we are going to do this thing called the AC method, which is going to, maybe for some of you, you've seen something like it. Maybe some of you already know how to try and factor this. I'm going to teach this as if you have no idea how to do this, all right? If you have a way that you're comfortable with, I don't want to confuse you. Stick with what you know, but it better work, okay? So here's the way we do 3 terms using what's called the AC method. You take the number in front of x squared, just the number in front of x squared, which is 4 here, and then you take the number at the back here, negative 5, and you multiply the 2 together. So I'm doing 4 times negative 5, and that would give you what number? Negative 20, right? All right? So we have that number sitting there. Now, look at the number in the middle. And just make sure you get the sign. It's positive 6, right? So the middle number is positive 6. So we have these 2 numbers now, right? These 2 numbers, negative 20 and positive 6. Now what I'd like for you to do is draw a big X like this. Put negative 20 here, put 6 here. And now you get to play a thinking game. All right, what you need to do right now is find 2 numbers which multiply to be negative 20, but add to be 6. So these 2 numbers, what you're going to be doing is trying to find 2 numbers that multiply to be this, but add up to be this. And so you have to start thinking about numbers, all right? So let's think about how could we get negative 20? What numbers could we multiply together to get negative 20? Could we do like 1 and negative 20? Could I multiply those two together and get negative 20? Yes? What would I get if I add them together? I get negative 19. That wouldn't work. Do y'all see that? These multiply to be negative 20, but they don't add up to be 6, do they? I have to do this and try and figure out if I can find these two numbers or not. And sometimes you can't. All right, it's not guaranteed that it will happen. So let's try. Couldn't I switch it around and go negative 1 and positive 20? Like I could do it that way. When I add those up, I get 19, right? Still not 6. So these don't work. Agree? Okay, let's think of other numbers. How about like 2 and negative 10? Those would multiply to be negative 20. But what do they add up to be? Negative 8. Nope. Could I switch it? Like that? Multiply to be negative 20, add up to be 8. That's not going to work. So those don't work. What are the next numbers? 4, you do like 4 and negative 5, right? Or you could do negative 4 and positive 5. No matter what, if I do these, if I add these up, I'm not going to get 6, right? So these don't work. Are there any other numbers that multiply to be negative 20? Yeah, not nice numbers, right? Not nice, clean numbers. There might be some fractions, but we are only trying to find numbers that are easy to think of. So do you all agree we can't come up with these two numbers? All right. Since we cannot come up with these two numbers, and we're pretty much done, like the only thing you could do is start saying maybe like 5 times 4, but you've already done 4 times 5, so we're kind of exhausted our list here. So since we cannot find the two numbers, since they cannot be found, then what we will say at this point is that we are done. Okay, and we will just box this and say we're done. We can't factor that any further. Sorry? All right, let's take a look at the next one. I'm going to have to get used to that. Let's look at number 5. This board is very glossy, but boy, it erases really nice. I like it. They put like some laminate film over the existing board, it looks like, over the break. All right, how about this one? Always start with what? Greatest common factor. So in terms of numbers, is there a number that goes into all of those? No. Other than 1, there's no number that goes into those. So you don't have a number coming out. How about variables or letters? Just a y, right? They don't all have an x. There's only a y. So a single y, and then what's left here? 24x minus 7y minus 30. And that's it. Now, when we look in here and we see this, right? How many terms do we count on the inside? 3. Now, that would mean you use AC method, right? However, do you see that we have x's and y's together? 2 variables in there. AC method only works if you have a single variable. So we would stop here. And AC method, actually, I'll talk a little bit more about it as we get to an example that will work. It only works when we have one variable in here and we have to have one of them like squared. It has to be squared and then just x and then no x, but we'll get to that. So we'd be done at this point also. We just pulled the y out, that's it. All right, let's look at number 6. We have 15xz plus 20x plus 6yz plus 8y. All right. First step. GCF, right? Is there a number that goes into all of these? No. How about, is there a letter that's common to all of them? Has to be common to all of them. There's not, right? So there's no GCF to pull out. This is the first time this has happened, right? But we're not done. Now we need to count how many terms there are. So how many are there? 4. And what do we do when we see 4 terms? 4 terms, we do this thing called grouping. All right, grouping. So here's how I teach grouping. You have your 4 terms listed out there, right? What you do is you go to your first term, and then to your second term, and immediately at the end of your second term, I like to draw a little slash through the 4 terms. But it has to be right after this. So but if this was a negative, you want to have that slash in front of it. Okay? Now what you're going to do, and I'm doing what's called grouping right now. So if you haven't seen this, again, I'm trying to present it like you've never seen it. What you're going to do is you're going to cover this up and then see if you can pull a GCF just out of these 2, ignoring these. So is there a GCF here? 5x, right? 5x. So what you do is you pull a little 5x, parenthesis, enough space for 2 terms, just these 2. So what would go inside that parenthesis if I pulled out 5x? 3z. 3z what? Plus 4. And we don't need the x because we already had an x out there. Okay, we agree with that? Any questions there? Okay, next step, very important. Don't mess this up. Always put a plus sign here. Okay, always put a plus. Now, cover up these terms and see if you can pull a GCF out of here, out of those. 2y. They both have a 2, they both have a 2 in them, right? And they both have a y. So I'm going to pull 2y here. Set of parentheses. Enough space for 2 terms. So what would go in here? 3z plus 4, right? Now, do you see that what's in parentheses here matches with what's in parentheses here? Yes? That does not always happen. When it does, it's a very good thing, all right? So what we can do now is we can say that this equals, let me write what it's equal to, okay? And then I want to explain why it's equal to this. This is equal to 3z plus 4 times 5x plus 2y. So what the hell just happened there, right? So let me try and explain it over here. If I wrote 5x times y, no, I can't use y, sorry. 5x times m, and then plus 2y times m. If I gave you this problem right here and asked you to pull a GCF, could you pull a GCF on this one? Do these have something in common? Yeah. What? The m, right? So you could pull that m out, and what would you be left with inside this parentheses? 5x plus 2y. Do you all follow that? Yes? That's exactly what this line is right here. Do you see you have 5x times m plus 2y times m. So since these are the same, right, it's kind of like the m is here. So what you're doing is you're pulling that out, and that's your m in front. Do you all see it? And so that's your m pulled out like a GCF in front of whatever was left here. When you pull this out, you're left with a 5x. When you pull that out, you're left with a plus 2y. Do y'all see that? Okay. The only way this works again, though, is that these two have to match. So if this would have been like 3z plus 1, you would be done. You couldn't do anything there. All right? This is called grouping. We're going to use this quite a bit. So we'll get some more practice with it.
Does it matter the 3z plus 4 that comes before? Like, does it matter what term comes first?
I'm glad you asked that question. Let me go back up to here and erase this. So what you're asking me is it okay if you write, I think, 5x plus 2y times 3z plus 4? Right? You're asking, and this is also correct. And the reason is because multiplication, you could like flip these over. This is the answer I told you it was, right? This is what I wrote on the board. You're asking me if this is okay. I'm saying it is. The reason I don't do it this way is because, well, quite honestly, the people who do this were usually just taught to put this and this in parentheses, and then whatever was matching, just put that in its own parentheses. But there's no reason why. I do it this way because I want my students to see that you're actually pulling a GCF out, and that's your GCF out in front. This is this, but they're the same at the end of the day. Okay, let's do another one. How about you try this one, number 7, and see how it goes on your own, and then we'll talk about it together. So go through the steps. Try and pull a GCF, and then count the number of terms. Let me give you 5 minutes, see how you do on that. Michael, Joshua, Emily, these are the exams. The grade is online, so I don't think the tests have the grades. Samantha, Robert, Andres, there you go, sir. I promised some bonus for President's Day. Was that in here? Right? Okay, I have not applied that to the grade online, just so you know. I need to go back and find my little sheet that has it. Yes. Yeah, I haven't. Anything that was bonus has not been applied to the test score. So, pardon? Oh, the answer to the mass or weight for a gram, it's mass. Yeah, it's mass. Raise your hand if you're done. Just want to kind of get a feel for how long it's taken people. Okay. I'm going to start working it up here. How many of you are to that point? Mostly everyone? This is the tricky part right here. Because on your second two terms, you don't have a GCF. I mean, really, like normally you would not pull anything out of this, right? But for grouping to work, you have to pull something out. And in this case, the only thing you can pull out that these have in common is a 1. So you have to place your 1 right here, and then in parentheses, x plus 3y. Right? Because 1 times this, 1 times that, you would just get back this. But the important part is that these two match now, don't they? So since they match, you pull that out, so you just write x plus 3y, and then in parentheses, what goes here? 2z plus 1. You have to have the plus 1 there. That's why it's confusing. People won't put that 1 there, and they'll just put like 2z here or something. You've got to have whatever's in front here and whatever's in front here. So you've got to have 2z plus 1.
If you flip the x and the 6yz grouping,
So just like change their position before you started. That's okay. You get the same answer. Yes. It would look different,
yeah.
but it would multiply out to be the same. Yeah. Okay, how about number 8? 8 just looks nasty, doesn't it? First step, GCF. Is there a GCF here? I don't think so. 35 is an odd number, right? These are all even numbers. The only numbers that you can pull out of 35 are 7 and 5, right? So no GCF, right? 4 terms. So you slash it right here. Now, what comes out of those first 2 terms? It's the biggest number that goes into both of those. What is that? 12? Yeah, it won't go into... 6? What do y'all think? 6? Try it. 6, and then how about the x's? X squared. And then what would be left in here? So you turn 6 into 24, you need a 4. How many x's do I need?
X.
Just 1 x, and then minus, because I need a negative, and 6 times what? 7. So 4x minus 7. One way you can tell whether or not 6 was the biggest GCF is by looking back at these and seeing if there's still something else that can come out. But you can't pull anything out of 4 and 7. Okay, now, very important, plus sign. And now what you need is to see if you can pull a GCF out of those. 5. So 5 comes out. That's the only thing that comes out. And what would you be left with? 4x minus 7 again, right? And these match. And since these match, we write down 4x minus 7. That came out. And then we're left with this and this in its own parentheses. Like that. Okay? I think we need a little bit of relief here. We're doing too much on the first day back, right? Are you all familiar with the NCAA men's? Well, there's a women's basketball tournament too. Basketball tournament? Yes? It starts, I think, today, if I'm not mistaken. I think there's a couple of games today and tomorrow to figure out the 64 teams that are going to play. Yeah, no. Yeah. If you have no idea, it's okay. Okay, so I believe ESPN is offering, I'm not sure if they're doing it this year, but they've been doing it for a while. They have this thing called a bracket. And what it has is it has like the first team, we'll call it team 1, is going to play team 2. And then whoever wins that game goes on to the next round. And they do this for teams 1, 2, and then teams 3 and 4, they play. And whoever wins that, they go on, right? There are 64 teams that are going to play. All right, so you're going to have, how many games are going to happen here in this first round? Round 1. There's going to be 32 games because there's 64 teams, right? 32 games. Those winners go on. So in round 2, how many games will be played in round 2? So there are 32 games here. That's not 32. 32 games. And in the second round, there will be 16 games, right? Because you'll have 32 left. And then these go down to the next game. So in the round 3, there will be 8 games. Round 4, there will be what? 4 games. Round 5, there will be 2 games. And then round 6, there will be what? 1 game, and that'll be for the championship, won't it? So they have this thing, where you fill out the bracket. They tell you in the very beginning, here are the 64 teams. Try and predict, before the games are played, who's going to win each of those games. And then try and predict of those winners who's going to win that game, and try and fill out this entire bracket correctly before the tournament starts. If you can fill it out correctly, you can submit it free. It's free online. You can go on ESPN.com and submit. I don't even think they limit how many brackets you can fill out. But you fill out your brackets, all right? And if you fill it out correctly, you win $1 million. Okay? I think Warren Buffett was funding this, if I'm not mistaken. So how difficult is that to do? Very difficult to do. In fact, I don't think that anybody has made it past round 3 with like everything correct in the first 3 rounds. I don't believe. I'll have to go back and check. But let's just look at just how many possibilities there are. Let's think about how many different brackets are possible. Let's just think about this. So let's not even care that Duke is playing UTSA and Duke's going to win. Let's just say each game is a coin flip. All right, let's just look at it that way. How many brackets are possible? So in the first round, right, there's 32 games that can each go one of 2 ways, right? You can have, yeah, I should have moved this over. This should have been, round 1 should have been here. It doesn't matter. So how many different ways can you fill out those first 32 games? How many different possible ways can you fill that out? It's not 32 times 2. It's 2. Let's do a simpler example. Let's say that there were 3 games. Okay, so you have these teams are playing. We'll call it A, B, C, D, E, and F. I just want you to see how we do this mathematically. Okay, so what's one way I could fill out just the first round if I only had 6 teams? So this could be what? I could go A wins, C wins, E wins, right? That's one way. I could have done A, D, and E. What else? A, D, and F. What else? B, C, E. Okay, what else? B, D, E. What else? B, D, F. I feel like I'm missing one here. A, C, F. There should be 8. 2, 3, 4, 5, 6. B, C, F. I'm missing one. What am I missing?
No,
Oh, yeah, sorry, I didn't count it. 1, 2, 3, 4, 5, 6, 7, 8. 8 possibilities, right? 3 teams, it could go one of 2 ways. We get 8 possibilities. That is 2 raised to the 3rd power. That's 2 to the 3rd is 8. With me? So in this first round of 32 games, how many possibilities are there? 2 raised to the 32nd power. Does anyone know how to do that in their calculator?
Yeah, it's.
Go ahead.
Just write it.
No, just give me the digits.
4, 2, 9, 4, 9, 6, 7, 2, 9, 6.
Is that right? Okay. Let's see. 1, 2, 3. So that's billion. So we're at 4,294,967,296 ways that you could just fill out the first round. Okay? Then you get to the second round, which is 16 games. So that's 2 to the 16th power. Then you get to the next rounds, 2 to the 8th, 2 to the 4th, 2 to the 3rd. So what you wind up doing to figure out how many different brackets there are, it's 2 to the 32 times 2 to the 16 times 2 to the 8 times 2 to the 4 times 2 to the 2 times 2 to the 1. So let's just, when you do this, you add these exponents up. So let's add those numbers up. What are those? Let's see, 48, 56, 63. This is 2 to the 63. Do you mind doing that? You're probably going to get an error, but 2 to the 63.
Inside scientific notation.
Oh yeah, give it to me then.
9.2237237 times 10 to the 18th power.
10 to the 18th power. Okay, so I've got to go 9, 2, 2, 3, 3, 7, 2, 0, 3, 7. Got to move that over 18 places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Put zeros here. Roughly speaking here. Okay, so get all these little things out of here. Okay. So ones, tens, hundreds, right? Millions, billions, trillions, and then how do they do it on Austin Powers? Like gazillion, right? I mean, there are names for these, but who cares? You're talking about millions of millions. Where's billion? Here's billion, right? Here's billion. How many people are on the planet?
7.5.
So do me a favor. Will you take that same answer?
Oh, I already.
Just do 2 to the 63rd
Okay.
and divide it by how many people?
7.5.
Okay, let's go with 8. Divide it by 8 with 9 zeros. 115 292 1505. So let's just try and get an idea of this. If every person on the planet, okay, filled out, is that right? If every person on the planet filled out 1 billion brackets differently, so you do your billion your way, you do your billion your way, everyone does their own billion, no one has overlapping brackets, okay? Then we'd be guaranteed to have one person at least win. One person would win. These numbers are astronomical, right? This is a huge, huge number. Now, the games are, it's not a coin flip. I mean, yes, Duke is going to beat UTSA, right? I think, right? But see, that's what makes it so difficult, is that you always have that one upset. You know, as soon as you have an upset, they call them bracket busters, because they've destroyed, like, usually in the first round, like 90% of the people's brackets get destroyed by that one upset. So no one's ever done it. No one's really even gotten close to getting it right. Anyway, but I wanted to show you that because it starts, I think, today They actually have 68 teams right now, and they need to whittle it down to 64. So there's a couple of games that are going to happen right now that are going to get it down to 64, and then the tournament starts. The brackets, yeah, that's what I'm talking about today. The bracket was released last night or something like that. So anyway, the mathematics behind the number of brackets out there is, but go for it, You can't win if you don't play. It's like the lottery, right? But your odds are better to get struck by lightning every day for the rest of your life and live. All right. Ooh, okay, so we did number 8. Yeah, let's move on. I think you can practice some more of these on your own. Let's get to some AC method. All right, so let's take a look at this, number 13. I have this dream, it's not realistic, but I have this dream that one day I'm going to teach a college algebra class and everybody's going to learn how to do this and know how to do it. But I may have better odds filling out a NCAA bracket. I don't know. This is the most difficult thing. I don't know why. It's just, my calculus students still have trouble factoring trinomials. I'm not sure why they do, but they do. So let's try to see if we can get a method that works here. Let's run through the steps. First thing, GCF, right? Is there anything I can pull out of all those? No? Right? So we're done with GCF. There's nothing we can do. So we count the terms, there's 3. 3 means AC method. AC method starts with, what we want to look for is this pattern. Do you see we have something squared? The x is squared. Then there's x to the first power, and then there's no x. You'll see that pattern? X squared, x, no x. When you see that, the AC method is what you want to use. So now what you do is you recognize what the numbers are. You need all 3 numbers in this. You need the 1 that's here, you need the -6, and you need the 8. And I said, which 2 are you going to multiply to start? The A, well, yeah, I haven't said what A and C are, but these 2 multiplied, right? So when you multiply those 2, what do you get? Positive 8, right? I'm going to put that in that little x, and then what number goes below it? -6. Make sure you get the negative. Don't miss the negative. And now you have to come up with 2 numbers out of your brain or use your calculator. You have to come up with 2 numbers that multiply to be 8, but add up to be -6. There are some things you can look at here that can help you. Like, if the numbers are going to add up to be negative, right? Then one of them has to be negative. Would you agree with that? But you can't have just one of them negative. Why not? Because they have to multiply to be positive, which means they both have to be negative. Now that's not super important to, you don't have to have that, but you have to start thinking of numbers. So what do you think? I like to start with 1 and 8. I always just start with the most obvious ones. So that multiplies to be 8. Does it add up to be -6? No, it adds up to be 9. So let me try -1 and -8. See, I'd have to make them both negative to multiply to be positive. If I add those up, I get -9. No go, right? Okay, what's the next numbers that multiply to be 8? 2 and 4 multiply to be 8, right? Adds up to be what? 6. That's not quite what I want. I want -6. So how about -2 and -4? Those multiply to be positive 8, and they add up to be -6. Here they are. We've got them. Now you're not done, okay? This method is, we try here at this college to all kind of teach the same way. That way if students go from class to class, it looks familiar. We put those numbers here like that. Just kind of